and an extremity of the lattice rectum is this. This we have done. One of its extremity of its lattice rectum. I think this question is 2. Question number 2 is same repeated here. Here one of that and an extremity of the lattice rectum is this. So this we have proved, but let me again prove it. Question number 4, just as question number 3. Question number 3 was having 2 times total length. It is 1 time only. It is a under root. This we have done in the first one, no problem. In 3 also we have done. Second, third, and fourth. They have the similar type of problem. So again, the parabola here is symmetric about axis of x. So this is the parabola. This is x-axis here, O, y, and y dash axis. This is x dash axis. Again, we have to find out between its one of its extremity of the lattice rectum. From the length of the arc, find that the length of the arc of the parabola y square 4ax intercepted between the vertex and an extremity of the lattice rectum is this. So here, let me take here lattice rectum is a and 2a. This is one of the extremity of the lattice rectum. Here it is a, x equal to a0 on a point. This is b point here. This only we have to find out. OB, the length of the from vertex to the one of its extremity. From O to B, the length we have to calculate. Okay. Here, y square equal to 4ax. The same question we have to do. Okay, so this can be done easily as we have done it in first, second, third. All the 3 questions is having the same type of problem. This is just a repetition of the first one. So here, length of the arc of the parabola y square equal to 4ax is between y equal to 0 to y equal to 2a. Simple. 0 to 2a only. Therefore, s equal to, which we have always done, y equal to 0 to 2a. Okay, this is under the square root dx dy whole square into dy. Okay, so the same formula we have to just apply as we just applied in the question number 3. Question number 3, we are having 1 plus dx dy whole square as 1 plus, it was y upon 2a. So y square upon 2a square, that means 4a square. It is nothing but y square plus 4a square, because we have to differentiate with respect to y. It was 2y equal to 4a dx dy. Dx dy therefore equal to 2a upon 4a. That means y upon 2a. Y upon 2 means y upon 4a square. This is 4a square. Okay, so this is upon 4a square. Therefore, this square root will be the same value. This is 1.2a. Let me take outside this 4a square root is, and the limits 0 to 2a. Under the square root, this is nothing but y square plus 4a square. Integration of this with respect to y. Okay, because y limits are given. So this is with respect to y. This is same 1.2a. It is 1.2 into y square root y square plus 4a square plus sign 1.2. It is 4a square log of y plus under the square root. This is y square plus 4a square. Limits 0 to 2a. Same value. Okay, so same question, but let me repeat it because the question is to be done. Let me write the answer here. it is 1.2 as we are calculating the length of the arc. It is nothing but 1.2 into 2a under the square root. It is 4a square plus 4a square plus 2a square into log of, it is 2a plus 2 under root 2a, because it is 8a square root, minus it is 2a square log of 2a. This we have calculated. Again, let me write it down. This is curly bracket here. If I write curly bracket, then it's okay. And this ends here. So this is 1.2, 2 to cancel out. It is nothing but 2 under root 2 a square, because a and this a. Okay, and this is plus 2a square. If I take common, it will be 2a plus 2 under root 2a divided by 2a log m minus log n. Okay, so this is log m minus log n. If I take it as in this way. Okay, so this will give us same value here. So 2a square we have to take outside. It is 2a square upon 2a. This is square root 2 only, plus it will be log of 2a, 2a cancel out. This is 1 plus root 2. The same answer is obtained. This is 2a, 2a cancel out, only a. This is a. In the bracket square root 2 plus log of root 2 plus 1 or 1 plus root 2. Same value we have obtained a outside under root 2 plus log of 1 plus root 2 or root 2 plus 1. Same answer, hence root. One of the extremity of the latest vector. The answer is this. Okay, so this is question number 4. Let me talk about question number 5. What does question number 5 say? Let me check it now. So we are calculating length of the arc or rectification. Question number 5th question says, show that the length of the arc of the parabola y is equal to 4ax cut off by the line 3y equal to 8x is this. Here the line is given this. So question number 5. Here the parabola y square equal to 4ax, okay, is cut off by the line 3y equal to 8x. Okay, so what are the points of intersection? Here the points we have to find out. What are the y coordinate here? So y coordinate we have to find out. So solving this equation, now here the curve is again symmetric to the x-axis. This is the curve here. Okay, the line will be like this because it is passing to the origin. Y equal to 8x upon 3. This is x-axis, and this line, suppose any line, this is the line here. This point we have to take. This is the length then between this point origin 0, 0 to this point, which is x and y coordinate. We will just calculate that intersecting point of this line, and this is the line here y equal to 8 upon 3x. Let me take. So this is a O point, this is O point, this is A point. Coordinates of A, let me check what are those points here. Solving, this is solution. So solving the two equations, we get, okay, so in place of y, if I substitute y equal to 8x upon 3, it is nothing but 8x upon 3 whole square equal to 4ax. This is 64x square upon 9 minus 4ax equal to 0. x is common only, so this is 64 upon 9 x minus 4a equal to 0. So here x equal to 0 and x equal to this much 4a upon, this is 4a upon 64 into 9. 9 will come in the numerator. So 4 16 times, it is 9a upon 60. This value of x here. X equal to 9a upon 16. Try to understand. X coordinate is 9a upon 16. What is y coordinate? Let me calculate that. And y is from this equation, where y is equal to 8 upon 3 into x. That means 8 upon 3 into x coordinate is 9a upon 16. 8 2 is 16. 3 3 is 9. It is nothing but 3 upon 2 only. The point is here 3 upon 2. Okay, so y coordinate here is 3 upon 2 here. 3 3 are 9, 3 8, 8 2 is 16. So it is 8 upon 3 into x. X coordinate will be calculated as this 9 upon 9 will come in the numerator, or 16 upon 9. If I divide 4a by 64 upon 9, 9 will come in the numerator. So this is 9 into 4 upon 64. 4 now 16 4 is 64. So 4 from 4 we have to cancel out this 64. It is 16 only. So 9a upon 16 value of x. Value of y is this. So these are the points. So let me solve the length for length of this curve. Therefore the length of the curve, and divide here, differentiating it with respect to y here. Okay, so differentiating it, the equation first. Differentiating it means the equation first. This is the first equation with respect to y. We get twice y equal to 4a into dx dy. Therefore dx dy, why? Because this is in the first quadrant of this, and the curve is going in the y coordinate. So by length we have to find out from 0 to this length. If it is in terms of this, then we find out ordinates x equal to this and this. If x is spherical to 4ay, in that situation curve will be like this, parabola will be, length will be in that ordinates. Now in this abscissa, dx dy we have to calculate. So therefore dx dy is 2 pi upon 4a, which is nothing but pi upon 2a. Therefore 1 plus dx dy, which we are always calculating, whole square is equal to 1 plus y square upon 4a square. This will give us 4a square plus y square upon 4a square. Therefore the square root of this 1 plus dx dy whole square is the square root of this whole. This is 1.28 under the square root. This is y square plus 4a square. Let me substitute this in the limits 0 to 3a by 2. So therefore length of the arc, therefore the length of the arc of parabola, length of the parabola of parabolic arc, okay, from y equal to 0 to y equal to 3 upon 2. This will be s equal to sine of integration. It is 0 to 3a by 2 by coordinate. Under the square root, this is 1 plus dx upon dy whole square into dy. Okay, within by, and now this is the value. Let me substitute this. This is 1.2a. Let me take outside 0 to 3a by 2 under the square root, it is y square plus 4a square into dy. Okay, so this is the value here. The same type of question is repeated number of times. It is 1.28. We have to prove that that answer is there. What is the answer? A into log 2 plus 5, 15 upon 16 value. Okay. This is 1.2. Integration of this will be, since integration of square root x square plus a square into dx is given by 1.2x under root x square plus a square plus 1.2 a square into log of x plus under root x square plus a square. This is the formula which we are applying here. Okay, since integration of this equal to this, so this is the formula. Here in place of x we have y. It is 1.2 y under the square root y square plus 4a square plus sine, this is 1.2 into 4a square into 4a square. Here in place of a square we have 4a square log of, it is y plus under root y square plus 4a square. Okay, limits 0 to 3a by 2. Okay, now let me substitute the limits and then final answer. Or let me do this. Therefore, s is equal to S is equal to 1 upon 2 into a. Okay, this is 1.2 y. What is y here? First 3a by 2 into 3a upon 2 under the square root. It is 3a by 2 means 9a square upon 4 plus 4a square plus 1.2 into 4a square into log of. Okay, so this is 3a by 2 plus under the square root this value, what it will be. 4 4 just 16 plus 9, 25 a square upon 4. This is 4 4 just 16 plus 9 is 25 a square upon 4 log of this. Okay, minus sign. Now when we put the lower limit 0, at 0 the first term will be 0, because this is y into y. 0 means 0 something, 0 into something 0, but this value will be y0, y is square 0, but this is 4a square, this is log of 2a. So 2a square into log of 2a. This is the repeated value. Okay, now let me solve it further towards the final answer. Okay, final answer is, let me now check it. It is 1.2a outside. This is 3a upon 4. Okay, from inside it will be 25 upon 4, that means 5 into a upon 2 will come out from the square root. This is 5a upon 2 whole square, so that means square root is 5a upon 2, because this is 25a square upon 4 plus sine 2a square. Let me take common. Then it is log of m minus log n. Log m is here 3a upon 2 plus this is 5a upon 2. Okay, because the square root of this is 5a upon 2 divided by 2a. So log of this value, let me take curly bracket here, upon 2a. So this is 2a. Log m minus log n. Okay, since log m minus log n is equal to log of m upon n. This we have applied here. This is 2a square common, then it will be log m minus log n. Okay, so what it is giving us 1.2a. It is 15 upon 16 a square. 8. It is 15 upon 8. I'm sorry. 4 to the 8 here. 15 upon 8 a square. Okay, plus sign is 2a square into log of. Let me check it. It is 8a upon 2, which is log of. Okay, 8a upon 2 means 4a upon 2a. It is 1.2a. If I multiply by 1.2a inside or 2a square effective common, what it will be? If we take 2a square common, it will be 15 upon 16. Because 2a, if I multiply by 2a in the numerator and denominator, it will be 2a square, then take common, so it will be 15 upon 16 plus log of, it is 2a only. Because 2 cancel out, a cancel out, sorry, 2 only, not a, but only 2, which is log of 2. The same value is obtained, this 2a, cancel out only a, sorry, this is only 1a. The answer comes out to be a within bracket log of 2, let me write first, plus sign 15 upon 16. We have the same value. A, okay, A, sorry, this one is a log of 2 plus 15 upon 16. Question. This one answer. Okay, same answer is obtained. So this is the question number 5. We have done question number 5. Same answer is proved, hence the proof, hence proved, if you can say, hence proved or hence the answer. Same answer is obtained. This is question number 5 here. So we are solving questions of rectification. Rectification means length of arc. Process of finding the length of an arc of a curve. So length of the curves we are solving. How to find length of the curves? That's the topic of today. Now questions up to now are clear. So let me take next question. What is question number 6 say now? Let me check it. Question number 6 say, in the catenary y is equal to this. Okay, a into cos h x upon a. Prove that the area between the curve x-axis and the ordinates of 2 points on the curve varies as the length of the intervening arc. Length of the intervening arc. Okay, it says that the area x-axis and the ordinates of the 2 points on the curve. Okay, so this is the relationship between the area and the length of the arc. So we have to prove that the area of the curve in the catenary case, prove that the area between the curve x-axis and the ordinates of 2 points. Okay, x-axis means ordinates of the 2 points. Let x equal to, suppose here a is there, okay, a is there. So let me take x equal to b to c. These are 2 points of ordinates. Between these 2 points of ordinates, x equal to, two ordinates, x equal to b to x equal to c, we have to find out what the 2 points on the curve varies as the length of its intervening arc. So whatever the area comes out to be, that area is equal to s times that area. So, okay, so let me find out first area. So area of the curve here, question number 6. So we have to prove that area A is equal to s times whatever the value, s times the value. Okay, is intervening. It says that find the A in the catenary case, prove that the area between the curve of the 2 points on the curve varies as the length of its intervening, length times s times the value of the area. Means we have to just find out that area is, or s equal to area times something, or we can say s is coming out in terms of area, or area is come as s times, because s times area. Curve varies as the length of its intervening arc. So let me take length of the arc between the two ordinates x equal to b to x equal to c. Let me take, because a is there. So okay, let me find out solution. Okay, so area of the given curve, here y is equal to, what is it? Y equal to it is a into cos hyperbolic x upon a. Okay, this is value of y here. So to prove that area A equal to s times the s is here, length of the arc. Okay, so area of the curve, this area of the curve on the given curve, let me write area of the given curve is given by sine of integration y into dx. Okay, this is y into dx between x equal to, what is, let me take two ordinates, x equal to, let me take b to x equal to c. Okay, so here the ordinates we have to take, here the ordinates are x equal to b to x equal to c. So we have to find out area as well as length between these two ordinates. Then we have to see that what is the value of the area. So area is this, therefore area A is equal to, we are calculating, let A, the area is equal to this. Let area is A. A is given this area. Let area is A. Therefore A is equal to this value, or therefore A is equal to x equal to b to c. Let me take the ordinates, and y here is this. This is A into cos hyperbolic x upon c into dx. What does it gives? It gives us A cos hyperbolic is integrated as sine hyperbolic x upon a, or x upon, yeah, it is x upon a, I think. 60 is x upon a. Okay, it is x upon a upon 1 upon a upon 1 upon a, because it's integration. A will come in the numerator. So this is a square here, with y equal to a into cos hyperbolic. So it is a square, and the limits are c to b to c. Sorry, here it is a square into, it will be integration of cos hyperbolic sine hyperbolic x upon c. It is sine hyperbolic. First is c upper limit. It is c upon a minus sine hyperbolic b upon a. Okay, so this is the value of area. A is equal to this, a square times sine hyperbolic c upon a minus sine hyperbolic b upon a. Now what is the length? And the length of the arc of the curve, length of the arc of the curve, y equal to a into, this is a into cos hyperbolic x upon a, is given by, okay, between, now here s equal to the sine of integration, here x equal to b to c, x equal to b to c, x equal to b to c. It is under the square root 1 plus, here x equal to, it is dy upon dx into dx. Okay, so that is how much? This is 1 plus x equal to b to c integration of, this is 1 plus, now this is d by dx. D by dx is this value. This is a square into sine hyperbolic, sorry, this is differentiation we have to calculate, not integration but differentiation we are calculating. D by dx will be multiplied, so a will be cancelled out. It's nothing but cos hyperbolic is sine hyperbolic, sorry, it is sine hyperbolic square. ddx of this is a into sine hyperbolic x upon a into 1 upon a cancelled out, therefore because d by dx, let me calculate here, is a into 1 upon a into sine hyperbolic x upon a cancelled out. This is nothing but sine hyperbolic x upon a. This is d by dx. D by dx is this value, this is square here, because this is whole square. So this whole square is sine hyperbolic square, sorry. Sine hyperbolic square, this value. It will give us into dx, 1 plus sine hyperbolic into dx here. So it is 1 plus sine hyperbolic square is cos hyperbolic square x. That means only cos hyperbolic. This is cos hyperbolic x upon a into dx here. Okay. Now we have to integrate this. So this integration will be sine hyperbolic x upon a upon 1 upon a. That means a times. Now limits b to c. So here s therefore comes out to be, let me write here. So s comes out to be a into this value, sine hyperbolic, a are taken common, is sine hyperbolic, first is c upon a minus sine hyperbolic b upon a. What is this value? This comes out to be a into capital A. But sorry, this is capital A. Here a into s. A is equal to s into, this is, if I write it as a into